Welcome to the viewers. Now we evaluate the double limits of a problem. In the earlier my videos in part 1 sections I discuss the definitions and the consideration of one examples, but now we given another examples. Let me write these examples. Limit u tends to 0, v tends to 0, uv u square minus v square by u square plus v square is equal to 0 established. Now for the solution, given epsilon greater than 0, we find delta NVD of 0, 0 such that mod of uv u square minus v square by u square plus v square minus 0, that will be less than epsilon. That is mod of uv u square minus v square by u square plus v square is less than epsilon. But we have mod of uv u square minus v square by u square plus v square, that will be equals to mod of uv u square minus v square by u square plus v square, that will be mod u mod v and mod of u square minus v square by u square plus v square. So we are getting, using the property of mod, we are getting these results. Now it's obviously we find mod u less than u square plus v square, root over of u square plus v square, and mod v also less than root over u square plus v square. You use this inequality, and as well as it is clear it is a smaller quantity, it is a larger quantity, because u square minus v square is less than u square plus v square. So mod of u square minus v square by u square plus v square is less than 1. So we are getting three relations. So using these three relations we have, therefore mod of uv u square minus v square by u square plus v square minus 0, that will be mod u mod v, and mod of u square minus v square by u square plus v square, that will be less than root over of u square plus v square and root over of u square plus v square, and it will be 1. So it is equals to u square plus v square, but here it is less than epsilon. Therefore uv u square minus v square by u square plus v square minus 0, that will less than epsilon if 0 less than u square plus v square less than delta square. We find already, because this is a circular neighborhood. U square means u minus 0 whole square, v square means v minus 0 whole square. So it is to be noted that 0 less than u minus 0 whole square plus v minus 0 whole square less than delta square. So it is a circular neighborhood. In here is a neighborhood, is a circular neighborhood, and the center of the circle is 0, 0. That is a neighborhood of 0, 0, NVD of 0, 0. So we get this result. But here if we compare here, that we find where delta square is epsilon, so delta equals to root over epsilon. So it satisfied the all requirement of the limits, definition of the limit, since it satisfy requirement of the definition of limit, and hence limits exist, it will be 0. Hence limit exists, that is existed limit is 0, and it's clear already because this element minus 0 is less than epsilon. So we finally say that limit u tends to 0, v tends to 0, u square minus v square by u square plus v square equals to 0. So with the help of epsilon definitions, we establish this result. Now let us consider another example. It is a very interesting cases. Limit as u tends to 0 and v tends to 0, uv by u square plus v square, it does not exist. Then prove it. How to prove? If we observe it, we have a clear-cut method, because we consider it, if we consider and if we observe these results, uv by u square plus v square. So if we take the functions, if we draw an axis of here u and here v, and if we take another straight line, suppose this v equals to ux, this is a straight line, and if we make any curves, but if we judge actually put on the basis of this line, we establish that the limit has not unique value. Since if it has not unique value, it does not have unique value, then the limit, it does not exist. So at first we follow the basic steps. Solution: let v equals to ux, then if we take as a function, suppose, then if we take as a function phi of uv is equal to limit as, if we take as a function phi of uv equals to uv by u square plus v square, then we can say that phi of u and ux is equal to u into ux by u square plus u square, sorry, here is the terms, we can't use it as x, we take it, if it's better if it not treated as x, because x, if we given here x, that can give a contradiction problem to all of us, because we treated x sometimes variable. That's why if we take as that will be better, or mu, that will be better result, because we take as a form of y equals to mx, that is a general equation form of a straight line, mu. And in many states, if we solve in this manner, and if they are taking sometimes the result limit x tends to 0 and y tends to 0, xy by x square plus y square. Then we as usual put y equals to mx. That will be the usual formula of a straight line which is passing to the origin. So here we give the line y v equals to mu. Now putting these results, here it will be u, just to strike off, phi of u and mu, that will be u and mu by u square plus m square u square. U square will be cancelled, so their result will be this. For different values of m, we get different results. Since this result is not unique, so limit doesn't exist. Because if any kind of limit exists, then it must be unique. So there is no possibility of the uniqueness, because we give different values of m, we can get different results. So it is not unique, hence the limit doesn't exist. So we can say that limit u tends to 0 and v tends to 0, uv by u square plus v square doesn't exist. Now today we end our discussion. Thank you.